Ensure the torque settings are calibrated before the next sequence.
Already checked. Moving to station 4.
As you can see, the sheet metal is stretched over the curved die, transforming the flat sheet into the complex shape of the fuselage panel.
The aluminum is submerged in the anodizing bath, creating that steam reaction as the electrochemical process begins to protect the metal.
We need the next panel up here. Coming right up. Watch out for the clearance.
The precision application of the sealant is critical before we secure the skin panels with the temporary Cleco fasteners.
Inside the F-16 wing, technicians meticulously route the complex network of fuel lines and wiring harnesses through the spars and ribs.
Steady, steady. Bring it down slowly now. Watch the alignment on the right. Looks good, push it home. All right, steady now. Center line alignment is critical.
I have green status on the forward sensors.
Clear to dock. Okay, bring it in slow. Watch the shaft alignment.
Aligned. Pushing it back now.
Clear. Clear on the left side. Bring it up another 2 centimeters. Holding steady. Pins are aligned.
Did you torque the B-nuts on System A?
Easy now. Watch the plumbing on the starboard side. We are clear for engagement.
Did you get the hydraulics secured?
Yes, just finishing the safety wire now. Torque is set on the fuel line.
Clear on the left side.
Okay, easy now. Bring it down slow. We're almost seated.
All stations, tow 41 proceeding to the paint facility. Clear right side. Left side clear. Roll synchronized.
All right, I'm pulling the transfer tape slowly.
The edges look clean, good adhesion.
We're at 20,000 pounds and holding steady. Any signs of seepage on the left wing?
Negative, the access panels are dry. Calibration looks good.
Weight confirmed. The center of gravity calculation is showing green.
Excellent. All parameters are within limits.
All right, bring her left just a touch. Easy now. Copy that, moving left. Clear to proceed another 10 feet.
Avionics panel 52 is clear.
Confirm. Check the sensor array alignment on your list.
Roger that. Looks good from here.
All clear for engine start, ma'am. Have a safe flight.
Roger that, Chief. Run the checklist. Starting engine 2.
Engine 2 is stabilized. Good start.
The spar mill uses multiple cutting heads simultaneously to carve the complex shape of the wing spar from the solid aluminum extrusion.
Connecting the primary ignition line now.
Connection confirmed and safety clipped.
Roger that. Moving to the secondary.
The automated TIG welding machine joins the aluminum sections with pinpoint accuracy.
Bring it down another few inches, slowly.
Clear. Hand me the torque wrench.
Alignment confirmed. Okay, bring it back slowly.
Holding at 0.2.
Perfect. Lock the turnbuckle and confirm torque. Okay, easy now. Watch the alignment pins.
Got it. Securing the lower latches now.
And the locking mechanisms are engaged. Okay, hold that steady right there.
Got it. Torque wrench ready?
Slow descent, watch the clearance.
We have alignment. Engaging wrench 1.
Torque wrench set to 7.5.
Confirmed. 3 clicks.
Okay, bring it in slowly. Watch the actuator connection point right there.
Got it. Applying torque now. Alignment looks good on the gauge.
Confirmed. Secure for retraction.
Ventral fin secured. Cable connections checked. Final sign-off complete.
The gap here is still too wide.
Let's try the .025 gauge on that forward linkage. Okay, the scales are steady at 1,000 to 250 kilograms.
Confirmed.
Easy on the port side.
A little lower, center's good.
Watch the clearance on the stabilizer.
Instability started right as I engaged the yaw damper here.
We tracked that spike in the data. What did it feel like?
A sudden pitch up, very sharp.
It's an honor to be here today. The new Avionics package is truly impressive.
Yes, the team did incredible work.